For the people who have not been here before, I'm going to say something that most everybody else knows, which is the Internet Court of Truth really is for the plaintiff. It's for somebody who wants to know what other people think about what they think is true or a lie. And the way it works is it runs like a court, but we're only trying the claimed truths or the claimed lies and not the people. So it has to do with giving the plaintiff some feeling about what they believe from the perspective of other people. And therein lies the value of what the internet calls absolute truth or absolute lies. And in fact, my background is in computational cognitive neuroscience. I'm a scientist, and I don't personally know what truth is, okay, or for that matter, lies, but I know how the brain computes on these things. Pretty much. I'm a scientist. What this particular case is, I'm doing exactly what we hope other plaintiffs will do, which is they have something that they believe absolutely is true, and then they pose it to other people to see how they analyze the analysis that the plaintiff gives. And so in this particular case, this is a major problem with understanding our species, which is that the humans took over the earth somehow, and we evolved to do it. But how long did it take to evolve, and how long have we been around? So the numbers on how long we've been around go something like 50,000 years old if you read the literature. And there's one very famous guy in linguistics, his name is Noam Chomsky, who basically was the father of modern structural linguistics. And he posited that the evolution of human beings happened in an evolutionary instant. What he meant by that, it happened in over a period of 30,000 years, but not over a period of 1,000,000 years or over a period of 2,000,000 years or something like that. What he meant was we became human relatively recently ago, and it only took a few thousand years. In other words, it's something that happened very quickly. He had a belief, which I actually concur with, which is the magic that happened that made us human was something called natural language, which is the language that you can learn from birth. Natural language can be learned by any human from birth, no matter where you are in the globe. As long as you're human, you can do it unless you have some clinical problem, but you can do it. And so natural language turns out to have language universals. In my world, the universals are a window on brain computation, on how brains compute, whether you're a human or a dog, believe it or not. But it's human language that gives us the clearest window on that computation. Chomsky pretty much agreed with that. I'm not alone in this belief. I've said before that there's a few hundred of us probably in the world that are scientists like me that have been studying this stuff for a long time. Most of us started as neuroscientists and went to natural language because it was a better way to figure out how the brain computes. And this whole idea of been called linguistic universals, properties of every natural language. For example, in every language spoken by humans, there are nouns and verbs, just to give you an idea. one universal. I also believe that natural language evolved very quickly, a few tens of thousands of years, probably in Africa. And these new things called Homo sapiens spread over the planet very quickly, again, in some number of thousands of years, not 100 years or anything, thousands of years, tens of thousands of years, a few tens of thousands. And we've since conquered the planet. And the basic belief we have is that natural language is an evolved product of the evolution of the capability of one brain to speak in the language of how brains compute. And that's our advantage over any other animal. It's everything else is secondary to that. But our ability to tell somebody, what to worry about it if they go over the mountain, or how to make a car, you name it, or how they're feeling, or what somebody else did or is planning to do, how explaining how you think about things. It's natural language. And the question is, how could natural language evolve so quickly? And the answer comes back because it comes back as a very short-term evolution, because natural language is, from a computational point of view, pretty much already there in animal brains. And it's a fundamental property of any living neural system. But it has certain properties which enabled natural language to evolve very quickly. And so what's said here as the truth for this trial is natural language occurred when people inherited the will to communicate through sound and also communicate directly in the language that all animal brains use through many millions of years, literally hundreds of millions of years. Once the will was there, the organization of speech, hearing, and the brain, natural language organs evolved quickly. And this is because neural systems already had developed how they compute on anything, and whether it's language or how you throw a ball or how your eyes neurally perceive reality. All natural languages is applying the same computational mechanisms that the brain applies to everything that it can perceive and do, to a desire to have one brain with high fidelity be able to communicate with another brain at high fidelity, in the sense of being able to describe what one brain can see going on in itself to another brain who can then understand how that first brain was thinking. And that's a property, that highly evolved thing. It's the reason that we see in the left side around here of the brains of most people, there are essentially two evolved language organs, one for speech and one for comprehending speech through your ears. So the one for speech is called Broca's area, and the one that's for comprehending speech is called Wernicke's area. And the two are right next to each other. On the left side, it's an organ. It does not exist in any other animal except humans. And what it knows how to do is translate everything else that's going on in the brain into speech, or from perception, map what it's perceiving out to everything else in the brain. So, for example, when you learn to throw a ball, you're involving a motor cortex area here in the back of your head and so forth and so on. And all the language area really is there to do is to take what you can say or what you can hear and translate it into what your brain already knows about throwing balls. So the way to think about this is that these areas are the Broca's area is like a motor control area. It controls your voice mechanisms. And these area is like a perceptual area, like the vision cortex, that understands how to, using the mechanisms that pretty much already existed, but are specialized and highly evolved to be as perfect as possible in terms of getting one brain to communicate with another brain, what that first brain is able to perceive and do to another brain that is also able to perceive and do things. That's why this happens so fast. So it turns out that the basic mechanism, the basic computational mechanism, is called a hierarchical organization of computations. And the easiest way to see it is actually using your eyes, which is in your retinas. Actually, I was talking to an eye surgeon 2 days ago, and I asked him the question. I said, how many neurons are in your retina, in one retina? And he came back with the same number I've been using. He said about 100 million neurons in each retina. And then between your ears and your head, there are about 100 billion neurons. And it's in understanding the amount of computation that goes on that you begin to understand why these claims. What your brain is trying to do with the input from your eye is organize what are essentially white and dark or one color or another dots into objects that you recognize as a chair or whatever. And that's actually a hierarchical organization of brain computation in any form of perception. So we know this true. This is true. So whether it's perceiving with your eyes or perceiving with your ears or perceiving with feeling or perceiving your own emotions, all that stuff is hierarchically organized by brain computations. And these hierarchical organizations are ephemeral. They don't last long. They correspond to you understanding a sentence or speaking a sentence. The next day, you've basically forgotten the sentence, but you may have learned something. Some other parts of the brain may have picked up on some information, or you may have found that particular sentence had incredible survival value. So your brain sat there and said, I'm going to remember that sentence word for word, and you remember it word for word. Okay. So you can remember things word for word, but generally speaking, these episodes that we both perceive in and move in are all hierarchical. And that's all language is. It's just an application of this hierarchical organization and hierarchical action organization. From your motor cortex comes a command to squeeze your hand. And that's actually a hierarchical set of commands that go down to the muscles and so forth and so on that cause your hands to clench. And then your brain is sitting there saying, yep, I did it. I clenched my hand. And what the miracle of natural language is, you can tell somebody else, I know how to clench my hand. That's the miracle. And it's crazy. And it evolved very quickly in terms of natural language, because natural language is not speaking a new language the brain doesn't already understand. It's being able to express it as a hierarchicalization of essentially speech sounds and either being output by your speech mechanisms or being input through your ears. the mechanisms largely don't care whether the hierarchicalization is going to your mouth or going to your fingers and writing words. They don't care whether you're listening to the words or reading them. It doesn't care whether or not you're watching a movie and maybe there's no sound, but you're still seeing sentences. One aspect of this that we know from, for example, film, if you take a course in film editing in LA, you say, where do I cut the film? Where do I cut the shot out and put it in? And they say, that's a sentence. If you just take a shot and make sure you can describe that shot in one sentence, like the guy turned around and looked at that tells you where to cut the film. What is it doing? What it's doing is saying, use your natural language. It will tell you where to cut the film. So you're now communicating one brain to another. Okay. And all of this is hierarchical. So this is basically the argument. And so the argument starts with this idea of there's a will. And by will, we basically mean what the brain already does, which is if I want to clench my hand, there's a will by me to clench my hand because I know I can do it. And so I have a will in my brain to be able to clench my hand. I learned that I can do it when I'm a little tiny kid, but I wouldn't learn it unless the brain came predisposed to have that will. So what I wanted to do was point out the last little piece of this, which is a huge piece. That will is inherited. That will is in your DNA. And kind of the purpose of this article was to talk about the fact that DNA creates memories. DNA does not create a blank computer. DNA creates a computer that's already programmed. And so I had some examples of that in this. I'm going to try to.
That's some pretty interesting stuff there, Bob.
Yep. Here's where we can bring it up. Okay, so this is I think y'all can see this. Can you see that these are grebes?
Yeah, I can see it.
Can everybody see this? Okay.
Yes.
Okay, so this is the main. Now watch this. This is the first time it was ever taped. It'd been known in biology for years how unbelievable this is. But these grebes have essentially never done this mating dance before. This is in their DNA. This is knowledge that's in their DNA. And if you watch this dance, the complexity of it, the length of it, the cause and effect that's taking place between the two grebes and so forth is incredible. And this is what we mean when we say your DNA pre-programs humans to have a will to speak and to know how to do it. All that really goes on is when we are learning a natural language, we're refining what we already know how to do, because if we didn't refine it, we would probably generate a new language because we don't have other people that are helping us refine what the word go means or what the word means or whatever. But this is one of the coolest things. If you watch this, you'll see how we don't even know exactly how one grebe, but they do. Okay. And they don't start this dance unless one of them's a man and one of them's a woman. Okay. And then they just follow it through, and it's just the most amazing thing to watch. This is what we mean by the will, and it's evolved, and it evolved very quickly, but experience the learning while you're alive. Learning refines it, but doesn't create it. If you don't have a will to speak, you will simply never learn. That will is not some decision on your part where you're sitting there thinking to yourself, I should want to speak. You just do it, because just the same way these grebes just do this in order to make sure that they're talking to another group, all the right results that will happen from an evolutionary point of view. Another interesting one that was out there, and I'm not going to play this one, is the talking fish. Here we're seeing a case where it also looks like the fish are talking with a fairly sophisticated language, and these fish are different than any other fish we know because of how well they can talk to each other. That talking conforms with the way we believe that any brain computes. This would be called a sort of an evolutionary branch. Fortunately, these fish did not become as good at natural language as we got, but the grebes were never going to get there, but they're demonstrating this kind of communication. There are things that grebes can't say to each other. There are things, if you watch this thing, that the talking fish can't say to each other. And there are things that dogs can't say to each other because they don't have natural language. But we all think alike, which is crazy. So that's the argument that I'm making. And what I'm going to try to do here is get the...
That is amazing though too about how animals. You got a dog or a cat.
Yeah, they know a little bit, but there's things that they can't. Cats can't say things to each other that people can say. I can't tell you tomorrow let's go to Atlanta, Georgia. I can't have one cat cannot tell another cat, hey, tomorrow let's get on a plane to Atlanta. It's just not possible. Okay. But humans can do that. That's what evolved very quickly, was a organ that allows us to do that, which is this Wernicke-Broca's area. And once we had that organ, then we could apply it to anything. We could apply it to reading and writing and so forth and so on, because that's where it goes through. And it's, so I'm going to go through I claim that this is true, and I'm curious what other people think. So is it the truth? I said, yes. The evidence for all this can be observed by any human. In other words, I can show you this stuff, take you through this stuff, and you don't have to be anything other than human to be convinced that these claims are right. Whether I can do it in 15 minutes is a different question entirely. Okay. Is it the whole truth? I'm a scientist. Anything is the whole truth is almost impossible. Is it nothing but the truth? Everything I say, I think is true. But I don't know a lot of things that I don't know about how all this works. But I know a lot more than what I can talk about in 15 minutes. I've been in these studies for over 50. I published my first paper on this in 1973. What's the deceit? The deceit, there's no deceit. I'm a scientist. I don't like deceit. What's the motivation behind the truth? And my motivation is, I'm a scientist, is to be informative. What's the social acceptability of the truth or lie? As long as I'm doing my science and I'm telling the truth, I think I should always be, whatever I say should be acceptable. 400 years ago, they killed people like me. This was the era when they killed the natural philosophers. The Inquisition killed natural philosophers. What label would improve the social acceptability of the truth or lie? I gave it an answer. I believe the description organizes a lot of what is known about human history in a plausible evolutionary framework. In other words, if you follow what I'm saying, you too would agree that what gave us the power to conquer the earth so quickly and to, basically be in every part of the earth is this thing called natural language, and to literally dominate and now effectively control our own destinies, for better or worse. What I'm going to do is go over the jurors, and each juror should just give us a 20, 30-second view of, and I'm very interested in summarizing your verdict. I saw that a lot of people agreed with me. I have no idea why you agreed. I never understand, even though I've taught for many years, I don't pretend to understand whether or not people actually believe me, even though I believe what y'all think. So, juror one.
Okay, so I don't exactly know a lot about the topic, and I said so in most of my answers, but I said I am definitely willing to learn, and I think I did learn a lot from you. Yeah.
Fantastic. Thanks. And I'd said earlier that there's only about 200 people like me on Earth who've been doing this for so long. And we're not a real popular group of people, and we're not paid very much. We don't make money. But we're dedicated scientists on how to, and there's about 200 of us. And so it's not surprising that you don't see this stuff in high school and college. Juror two.
Hello.
Hey.
My summary, I think I would agree with juror number one, as I'm not very familiar with the topic, but what I can say, it is interesting, but it definitely took me some time to finalize my verdict, because it isn't something that is talked about, but it's very interesting, and the way that you unpacked it in the case is very interesting.
Thanks. So I appreciate that. By the way, when I jumped into this, it took me years to see this stuff. So what you're actually listening to is somebody who spent, literally the first work I did was when I was in 1968 and 69, and I published it in 73 when I was 18 and 19 years old. And so that was 58 years ago, 55. And this is what I've been doing for 55 years. And so most of the time I could never get published because the existing science thought I should be doing what they call wet neuroscience. And I found that not as productive as studying this stuff through natural language, and nobody would pay for that. So I lived most of my life on very little money. Juror three.
Okay, firstly, like juror two and juror one, I don't know much about the topic, but I tried to go on Google and search. And my conclusion is that I do agree with you that the idea that humans had the capacity to communicate and it is built through biology is actually true. But like I felt like the part where you said that none of them had to it felt like an oversimplification over the fact that of the evolution of language was more likely like something that is complex because it involves the brain and speech mechanism. But I tried to do research to try and find the timeline, but it just said that there's still an ongoing research about the timeline. Yeah, but I do agree with you, and it's actually very interesting. I think I want to research more about it because it's something that we don't talk about, and it's very informative because we don't actually talk about it more.
Yeah. In a few of my papers, some of the people like me have written actually really good books. So there's one book by a guy named Znowski. He's now retired, but his book is called The Deep Learning Revolution.
The Deep Learning Revolution. Okay, thank you.
Yeah, Deep Learning Revolution, and it's by a guy named Terence Sosnowski, who I've known for 40 years. But yeah, so he's one of me. Another guy who's one of me is a guy named Jeff Hinton, who just recently resigned as the chief scientist for Google. And Jeff and I have known each other since the 70s. I don't know how many years that is. He and I have essentially the same background. He could be listening to this and going, oh, yeah, thanks, Bob. Juror 4.
Okay, so I don't know much about the topic, and I do agree with you. I said yes, and my small summary is the evidence for these claims can be observed by any human and described in natural language. And when I said no, is it the whole truth? I said lying and deception might have played a role in human social dynamics and survival. It's not the whole truth that humans are solely driven by a natural evolution of lying.
Yeah. So one of the things that these newer areas that I got into was this Mendaciology, which is the computational cognitive neuroscience of lying and deceit. And it turns out the only known cure for deceit is that you recognize that you're being deceived. And that will make the deception not work. It's what that basically says, and this is something to think about because it's crazy, is that your brain likes to remember what's true. And when you're deceived, you think something is true that's not. Somebody else knows that it's not true, but not you. When you realize that somebody is deceiving you, what your brain is doing is computing on truth. It's actually going, I now understand what's going on. This guy's trying to deceive me, so he's telling me a lie. And that's the truth to you now. And that cured you from, or gives you a ability to deal with the fact that guy's deceiving you. Now, there are traces that get left in your memories where the deceptions that happen over a period of time can still have hold over you, even if you now know that the guy had been lying the whole time. Okay? From having been deceived completely, but recognizing deception is just simply recognizing truth, and being deceived is just believing that something is true that's not, or is not what is, or it may be factually true, but the motivation behind it was not to inform you, it was to deceive you, talk you into something that you would believe, even though it was for a foul, bad motivation, and so forth and so on. So your brain is really organized to keep track of truth in its memories. And that's what makes deceit possible, by the way, because it wants to recognize when it's being deceived.
Bob, I have a question about that.
Yeah.
So, traumatic brain injury. I did lose the memory of my head amnesia for about a couple of weeks after it happened. But I noticed as my memory started coming back, I remembered more of the, I don't know if it was because the people I was around or what, but there seemed to be more truth of things to come out than lies about what happened. Is that
so you actually mentioned 2 or 3 things, but one of the things, there's something called anterograde amnesia, which I don't know whether you ever heard of it, but if you have some injury, you may have, the memories may not be recorded in the first place, or some part of the memories may not be recorded in the first place, so you don't even know what happened because you were just blacked out, because your brain was not keeping track of, it was not forming new memories. And then there is the other thing is that you can have a situation where you are forming new memories, but they are incorrect, i.e. you're being deceived, and which is a different thing than anterograde amnesia. Anyway, I could talk on this for an hour. I don't want to go there.
that's a good trial right there, Bob. Right?
Juror 5.
Hi, everyone. Much like the other jurors, I had zero to no knowledge about this specific topic. but I'm someone that tends to go down a rabbit hole when I come across something that I don't have knowledge about. So when I came across this case, I tried to do a lot of research myself. Clearly, there are not many of you because it was quite difficult finding information, but the way that you presented the case and just all the facts that you've given us tonight, if anything, I feel that we're all walking away, yeah, with a whole lot more knowledge than what we had coming into it. So
Yeah.
thank you for that.
So an interesting thing to me, and I've actually written a paper on this one, is because natural language is so natural to us, we tend to not notice when it's natural language that did it. We always think that natural language is there, but we don't recognize the role that it's playing. And so a lot of things get explained without recognizing the fact that what was really explaining what happened was the fact that two people could talk to each other and say the things they said. Okay. So natural language is really both a great benefit and is like any other reality, it's also very dangerous. And so it's just sort of wow. Are we on Juror 6 yet?
Yeah, we're on Juror 6 now.
Are you Juror 6?
Okay, I said yes, I agree. And then my supporting text was yes, it's true. And there is a body of evidence that shows that the ability to lie or deceive has evolved as a natural part of human behavior.
Yeah. So my dissertation back in 1976 was on the formation of causal inferences. It was looking at the fact that you could directly observe that if somebody said John threw the ball, Bill ducked, that those two sentences, the causal relation that because John threw the ball, Bill ducked, that inference is observable by anybody. And so it is a human behavior. My PhD is in psychology, experimental psychology. So my PhD was on this inferencing that occurs between sentences where the inferences are never stated, they're never asserted, yet everybody agrees what the relations are. That makes this direct observation, that makes this the subject of science. And so you could then study that. So you could study things that are not explicitly stated. Language is a behavior, you could study that, but you can also study the meaning that comes out of language because everybody, in most cases, everybody will observe the same meaning unless something is ill-formed or not done right. When you use the term behavior, yes, big time. So this all comes out of behavioral psychology, even though it doesn't sound very behavioral. So Juror 7, or am I already past? Is Juror 7 here?
Hi, sir. I'm not quite familiar with this topic, but what I can do say I agree with you because even the research, it doesn't give as much information for me to be able to speak. So yeah.
Yeah.
But I do agree with everything that you have said in this case. And it's quite interesting.
Good. I'm happy. Y'all are all making me very happy because I wrote this paper probably 2 or 3 years ago, and I never wanted to show it to anybody because I felt like everybody would call me crazy. But I was sure I was right. Yeah. So it actually makes me feel really good that y'all are. So Juror 8.
Greetings, everyone. I also agree with everyone else, and I'll just, from my research, read my summary. What I said, I feel language has been a really game changing for our species, as it allows us to share ideas, tell stories, and build relationships. So I actually say that the evolution of language is closely tied to the evolution of our brain. As our brain grew and became more complex, we developed the ability to process and understand complex sound, words and sentences. It's an amazing example of how our biology and culture are intertwined. And also, I will agree. I think there's still debates in scientists, but I do definitely agree with the plaintiff. Thank you.
Thank you. Okay, so this is good. I don't really have anything further. Does anybody want to make any other comments or have any questions or anything? Okay, so this sounds great, and thank everybody. It was great that everybody showed up. So we had 8 people accept the invites, and 8 people showed up. So our normal expectation is that if you run a trial, you may well get 8 people signing up, but typically the typical number that shows up is like 6. But even if you run a trial and only 2 people show up, that ain't bad because you get 2 people's opinion and get to talk to them longer. So thanks a lot. I appreciate this. Y'all actually made my day. I was having a pretty bad day today.
Glad to help make your day better.
We'll see y'all.
Thank you, sir.
Thank you.
Bye-bye. Thanks.